Yes. All right. So we are going to look at straight line motion. So going up and down or left and right. So not different directions, straight lines. And when it goes at a constant acceleration. Okay. Constant acceleration does not mean constant velocity. Constant acceleration means it's going faster. Let's say it was stationary, then 10 meters per second, then 5 meters per second squared, 10 meters per second squared, 15 meters per second squared. Not squared. Seconds. Yeah. Alright, but it's not going to speed up, slow down, speed up, slow down, speed up a bit. Say again? Yes. Yeah? Constant acceleration.
Is it increasing velocity?
Yes.
So increasing velocity.
Yes. Alright, so that is the type of motion that we're going to look at. The only thing that you need to know there is it's not going to become too complicated. Okay? Right, now in grade 10, we did these formulas. Alright? Later on in this year in mathematics, you're going to do derivatives. And then you're going to take one equation and you're going to derive other formulas. Okay, so in mathematics, you'll prove how you get to these formulas. Science, we're just going to use them. Okay, so these formulas will be on your data sheet. VI stands for initial velocity or beginning velocity. VF, final, acceleration, displacement, time. And then each of these equations have something missing. So they're independent of certain things. Like this one does not have displacement. This one does not have final velocity. Okay, but all of them will have initial velocity. So in a question, if you're not given initial velocity, then you know you must go calculate it, figure it out. Then another reminder from grade 10, if we say an object starts from rest, it means the initial velocity is 0. If it stops, final velocity is 0. If it speeds up, then the acceleration is positive. If it slows down, then it's negative. And then I said, remember your info table. Okay. So let's look there at an example. It says, a car starts from rest and accelerates at 5 meters per second squared. Calculate the displacement after 4 seconds. Alright, Tazwa, let's start with you. Give me anything I can put in my info table. Initial velocity is 0 because it says it starts from rest. Orifilwe, the next one is what? 5. Next one, Mukatso. Time is 4. Then, Botimelu, what did they ask? What must we calculate? And what's the symbol for that? Delta x. So then I tell myself I do not have final velocity. So I need a formula independent of final velocity that does not have final velocity in it, which is the second one. Delta x is vi delta t plus a half a delta t squared. Right, then you substitute your values. Remember, you must substitute all the zeros. So initial velocity is 0, so you show that. Plus a half, the acceleration is 5, time is 4. Yeah, but 0 times 4 is? Nee, without a calculator, Filu. Okay, it's actually Bukamuso's turn. Bukamuso? 4 squared is? Times a half is?
16 times a half.
Shh. 16 divided by 2. 8 times 5. 40 meters. No, because it's distance or displacement. Displacement is meters. Velocity is meters per second. Okay. Says there, a Hercules transport plane, just a plane, lands at 108 kilometers per hour at the edge of a 600-meter long runway. If the plane can decelerate at 0.8 meters per second squared, will it be able to stop on the runway? Right, now this type of question you can do one of two ways. Okay, you're going to need more lines. Right. Info table. Information that they give us repeatedly. What do they give us? Okay, is what? It says it can decelerate, so it's negative 0.8. So Nomta, more information. Okay, does it say it used 600 meters? Does it say it traveled 600 meters? It just says the runway is 600 meters long. Is it initial or final? It lands and then it comes to a stop. So it's in initial velocity is 108 karabu kilometers per hour. And that gives you 30. 30, 60, 90, 6, 12, 18, 108. Nee? Alright. Sharp. Do they give us more information, Lorna?
No, you must calculate the if.
Okay, so this is why you have two options. Because you can either say, alright, thus, will it be able to stop in time on the runway? So, it didn't say it did stop. Will it be able to stop? So, in the first one, you can say, alright, if the final velocity is 0, if it stops, if it comes to a stop, how long or how far, what distance did it take? Does it take the entire 600 meters? Or does it take less or does it take more? Or you can say, all right, if it's going to travel 600 meters, what will the final velocity be? Is it still moving after 600 meters or has it had time to stop and reverse?
So you switch pair.
Okay, so we have one of two options. The first one is the easier one. Okay, so let's see the easier one. Or let's look at all of them first. We do not have time. So we need the formula independent of time. Yes. And you're going to use that for both because in both scenarios we do not have time.
So what's x?
Right. So for the first one, the final velocity is 0. The initial velocity is 30 squared plus 2 times negative 0.8 because it's coming to rest. And now we want to calculate x. We want to know how long did it take? What distance did it take?
X is
62,5 meters. So the question is not calculate the distance it will take to stop. The question is, Will it be able to stop on the runway? So we must answer yes or no. That is smaller than 600, so yes, it will be able to stop in time. Okay, let's look at a different way of looking at it. We want to know what will the final velocity be after it has traveled 600 meters. So that is still 30 squared plus 2 times negative 0.8, and now the distance is 600. Wait. This is 900. This is negative 1.6x. Take that to the other side. So 1.6x is equal to 900. Okay, now you see on the right hand side you have a bit of a problem. Because you get the final velocity squared to be negative 60. Negative 60. And to get rid of the square, you must square root it. And you can't square root a negative. So here you have to defy the laws of mathematics. Okay, to get sort of an answer. Then negative already tells you that it's actually going in the negative direction. So it has had time to stop and reverse. You see. But it doesn't make like a sense. But anyway, you will get the final velocity. So then you're going to put the square root sort of there. And you get negative. Because you're going to put the negative 7.75 meters per second. So it means it has had time to stop and reverse. But still, it's a bit fishy. So I won't advise you to use this route. I would rather go that one, where you don't have to do square root of a negative, and mathematically you are breaking laws.
So if they ask you, will be able to make us maybe
0. Alright, so this was the type of questions we did in grade 10. Then we did graphs. Now you are going to do three types of graphs. We have done 2 in grade 10. So we're going to revise these 2 and then we will get to the third one a bit later on. Now something I forgot to mention at the beginning of this lesson. Physics paper, multiple choice, question 1. Question 2 is Newton's laws. Question 3 is projectile motion. Question 4 is momentum. Okay, so you've done 2. With Newton's laws, what is very important that you are going to do? Free body diagrams and yes, choose a positive direction. With momentum, what is important? Choose a positive direction. This chapter, choose a positive direction. The first 3 questions, that's very important. Then you get to a question where it's not that important, blah, 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 blah. But those first 3, very, very, choose positive direction. Choose positive direction. First 3 questions. Okay, so here, very, very big. Let's make it here at the first page. Positive direction. And you stick with that throughout the whole question. Now, normally in this question, how we do that is your positive direction that you choose is your first motion. Meaning, if it goes to the right first, you choose right to be positive. If it goes up, you choose up to be positive. Okay, first motion, you choose to be positive. I do not have. Okay. The first type of graph we're going to look at is a position time graph. They also refer to it as a distance time graph, distance or displacement time graph. It depends on the scenario. So position, distance or displacement, but it's all meters, all in meters versus time. Right, and I told you from today or from grade 10 until the end of time, when you get a graph, you ask yourself, what does the gradient tell me? Okay, now in this chapter, you're going to do a lot of graphs. Okay, and you must make a note in your head, graphs are my friends. They're not the enemy. Okay, you don't get nervous when they give you a graph. You don't get nervous when they ask you to draw a graph. Why not? If you look here, this is a report that we got from all of the subjects in our country regarding the results of last year's matrics. It is, I don't know if you can see it now, 328 pages. I must read this. What am I gonna read it? Scan. Ooh, graphs are my friends. Because what will the graph do? It will give me a summary of what is actually written. Okay, so I can see here. This is imaginative. Thank you very much for that. I see the percentages, more, and then I see the curve that goes up like that. So what do the most learners think? They get about 60% for English first teaching language. Alright, and what do I look at? I look at the gradient. Yes? It shows a steep incline here and a steep decline there. This is a worry. Anyway, this is what my subject is. Alright, so a graph is your friend, especially in this chapter. Okay. So, get a graph, I smile because more information is given to me at one piece of, than a lot of written stuff. Okay, you ask yourself, what does the gradient tell me? Now, how do we calculate the gradient again? Gradient is the change in y over the change in x. Ne? y2 minus y1 over x2 minus x1. Then you ask yourself, specifically in this graph, what do I have? I have position versus time. So the symbol for position is x. The symbol for time is t. Okay? Position is x. Distance is x. In meters. What do we measure position in? Meters. What do we measure time in? Seconds. So we basically have meters per second. Thank you very much. So when you ask yourself, what does the gradient tell me? The gradient tells me the velocity. Okay, so let's consider this graph. Okay, and I want you to fill in here. This is A, B, C, D, E, F. Okay, let's look at the graph. We see here the object starts from a zero position, wherever zero position is. Then it travels 60 meters. So it travels 60 meters. But you can see it travels in a straight line. Okay? So a straight line means a constant gradient, means a constant velocity. So it's not accelerating, it's moving at a constant speed until 60 meters. Then, for 5 seconds, it stays at 60 meters. So for 5 seconds, it stays. So it's stationary. Because the gradient is 0, the velocity is 0. It's not moving. Then we can see the gradient is negative. Negative gradient means negative velocity, means velocity in the negative direction. It was here.
Backwards.
Now it's moving backwards. Not decelerating, it's moving backwards until here, where the displacement is 0, where it started, and then it's moving in the negative direction. Boom, 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 and then it's moving forward again to its original position. If it was curvy, if it went like this or something like that, then there was acceleration. But because it's constant gradients, it means constant velocity, no acceleration. Alright, so they asked there, describe the motion of the object for each part. Whew. That was my exercise for the day. AB. AB. Okay, so we see constant positive velocity. So it means it's moving in the positive direction. So it has constant positive velocity. So it means it's going forward. Then BC, we saw that the acceleration is 0 after the velocity is 0, so it's stationary. Then from C to D, we see it's going with a constant negative velocity. Same thing for DE, ne? Constant negative velocity. And then for EF, it's again constant positive velocity. This positive means forward. This negative means backwards. Okay, now they ask, calculate the velocity of the object for CD. Where do I find velocity? There, gradient. Now, if they say use the graph, then you must calculate the gradient. If they say use equations of motion, you must use these things. If they don't say anything, you can use any one. All right, now wait. Can you see here in this graph we have no acceleration. The acceleration is 0 throughout. Okay, if the acceleration is 0, then you can use this formula. But that formula is not on your data sheet. Where do I get this formula from? I get it actually from your data sheet, which is delta x is equal to vi delta t plus half a delta t squared. Because if the acceleration is 0, then that is the same as that, just rearranged. Alright, so you don't have to go memorize this off by heart. You can just look at this one and fill in a 0 there. Okay, where are we with our questions? Fatima.
Number 2, if they don't give us the what? Then you must use the graph.
If they say use the graph, then you must calculate the gradient. If they say you use equations of motion, then you must use the equations. Okay, Fatima, which option do you want to use? The graph or equations of motion?
Equations of motion.
Okay, equations of motion. So I am going to say velocity is the change in time over the change in x over the change in time. Okay, let's look CD there. Remember, change in means final minus initial. So the final D is 0, the initial C is 60. So it's 0 minus 60. You must show that 0. And then D is 30 and C is 15. And Tashwa, back to you. In your head. It is -4. Are you allowed to leave your answer in the negative? No. That negative means something. It means. So 4 meters per second backwards or in the negative direction or to the left. If they said we're moving to the right or not. Not deceleration. It depends what type of graph this is. If it's a precision time graph, no. It's a velocity time graph, yes. So careful at what your graph, the graph that you're busy with. What? No, then you'll say the change in y over the change in x. And it will be exactly the same. Okay. Well, you're going to read the axis, ne? Alright, next one. When we are busy with a velocity time graph, the first thing you always ask yourself, what is the gradient? Tell me. So gradient is the change in y over the change in x. For this graph specifically, what's on my y-axis is velocity. And on my x-axis is time. I'm going to zoom in there. Velocity is measured in meters per second. Time is measured in seconds. 100% from you this term. Okay, so the gradient gives you acceleration. Okay, then this type of graph, a velocity time graph, gives you more information. You can look at the area under the graph. Now be careful, area under the graph does not mean this part there. Area under the graph means between the line and the horizontal axis. So that there is the area under your graph. Okay, now to calculate area, how do we do that again? Area, it's a bit difficult here because we have squares or rectangles and triangles. Okay, but you'll get to the same answer, it doesn't matter which one you take. So let's take a rectangle is length times breadth. For this graph specifically, my length, let's take length to be velocity and breadth is time. Okay. Velocity is measured in meters per second, time is measured in seconds. I'm going to zoom in there. What is meters per second times seconds? Yeah. AB minus 1 times B is the same as AB times B. M. And what do we measure in M? We measure distance.
Also, like, so the area is the exponents.
Okay, so the area under the graph gives you the distance or the displacement. Okay, let's, no, so I walk 1, 2, 3, 4, 5, 1, 2, 3. What's the distance that I've covered?
0.
5 minus 8.
Oh, you minus.
Distance is 8. The distance that my legs travel is 8 steps. My displacement is the direct line between my start and my finish. 2 meters.
Oh,
The distance
the
is
head and tail the. Is it the head and tail?
Yeah. All right. If I was wearing my watch, it would have said calm down. Okay. Right, let's look at the type of motions. Let's consider the velocity time graph. The car initially moves to the right. So when we start our story, it's already moving at 10 meters per second. And you can see that velocity is constant, 10 meters. Then, wat wil julle tweede agter? Ek hoop julle trek spykers uit nie. Is julle op 'n selfoon? Teken julle. Het julle niks reiswerk nie. Kyk vir julle twee daar agter is tydskrifte. Wat 'n tydskrif en blaai daardeur. Daar doen. Right. So it's moving at a constant velocity. Then it is slowing down until it comes to a rest. Okay? Die van wie aan sien? Oh. This was yesterday's.
Yo.
Yeah. So you know each grade has a grade head. Okay? I'm the grade head for the grade 10s. So everything that goes on to the grade 10s, I know.
Yo,
What
trouble.
class is that? No, was it 10?
Huh? I don't have a
Trouble.
register
What is
class.
our head?
Grade Miss Phsc.
Wait,
Not
so-
Ella, the short one.
Yo.
Alright. So, okay, so it's moving at 10. Now this here, the negative does not mean it is going in a negative direction. Negative gradient means negative acceleration, means it's slowing down. So we're moving at 10, and then I'm slowing down, 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 until I come to a stop and C.
Okay.
Then from C to D, what's happening? It is going in the negative direction. It's going from 0 to 6. So it's speeding up in the negative direction. And then it's going at a constant velocity until it comes to a rest. Right, so just because this looks like a straight line or looks similar does not mean it has the same motion. Yes, both is negative acceleration. This one is slowing down until it comes to stop. This one is speeding up in the negative direction. Right, so it says they describe the motion of for each part. AB we say is constant positive velocity. So it means it's going forward in the positive direction constantly. BC was negative acceleration, and you can go even further by saying slowing down until it stops. Yeah, negative A. Yes? Yes, yes. Until rest. Yeah. Then CD is still negative acceleration, but it's actually speeding up in negative direction. And then DE means it's constant negative velocity. It's not coming to a stop. It's not slowing down. It's just constantly going backwards. Nee? Okay, now they ask, calculate the acceleration of the car from B to C. Acceleration, where do you find acceleration? The gradient. So now let's practice doing the gradient one. So they want that acceleration. Let's look at the gradient. Is the change in y over the change in x. Change in means final minus initial. So for BC, final is 0, initial is 10. And then the time, final is 6, initial is 2. Where are we? What if you look? In your head? 10 divided by 4? Yes? Yeah? It's 2.5, negative 2.5. Are we allowed to leave our answer in the negative? No. So 2.5 meters per second squared, negative acceleration or in the negative direction or slowing down. Yes. The reason why I say negative acceleration is in Afrikaans, deceleration, the word is vertraag. And vertraag means the same as retarded. And that's rude. Huh? If you ask that question, you completed the sentence. Alright, next question says, calculate the distance the car traveled. Is that spelled correctly? Traveled. 2 L's?
Yes, 2 L's.
Anyway, the distance the car traveled from C to E. So from C to E. The distance the car traveled from C to E. So we want that there. Okay, the area there. But, careful, I don't know the formula to calculate that area. I don't know it out of my head. Maybe there is one. But I'm going to split it up into a triangle and a rectangle. Okay, so the distance is the area of the triangle plus the rectangle. You do not have to write that part down in a test or in an exam. Then this is a half base times height and length times breadth. Again, you do not have to write that down. You can, but you don't have to. Now, distance is a scalar. A scalar only has size or magnitude. So you do not have to put in the negatives in your values. If they asked for the displacement, then you put in the negatives for the direction. But since they asked for distance, you do not have to give that. Okay. So if we look there at this triangle, our base is what, Dimakatsu? Four. From 6 to 10 is 4. And our height, what do we look? 6. Now remember, you do not have to put in the negative because it's a scalar. If it was if they ask for displacement, then you're going to fill in negative 6 because it's in the negative place. Height, base, for a triangle. Okay. Then we saw the length for the rectangle. Okay, 6, it doesn't matter which one you look at. And Refilu, the breadth. She looked at that part, so you're going to look at that part. But from 10 to 12.
What did she say?
Meters. Alright, so that is your grade 10 work. Okay, now I'm going to stop there for today. I'm going to introduce the next part just